Hello everyone. Today I'm going to deliver a lecture on nature of earthquake vibration. The topics will be covered to divided in two part, which is introduction and basic concept of earthquake, which is include earthquake terminology and ground motion, and another is earthquake magnitude intensity, which is earthquake magnitude intensity difference between magnitude intensity and empirical relationship uh, uh, for estimating peak ground acceleration PGA and PGA during shaking and different intensity. And uh, and the last one and the last one some math examples. Okay, so let's see first one, the introduction and basic concept of earthquake terminology. So, what is the earthquake? As we search in Google, ChatGPT, the Earth is in the sudden shaking of vibration of Earth surface caused by release of energy stored in Earth crust. This energy is typically released due to the movement of tectonic plate and volcanic eruption and human induced activities such as mining and reservoir induced seismology. As some key features, which is causes of earthquake, we know the tectonic activity and volcanic activity and human activity, and focus and epicenter we know here. If we show the some focus in the point of inside earth in causes the origin, and epicenter and seismic wave and magnitude intensity and tsunami, so many things are included. So let's see another causes of earthquake. According to elastic rebound theory, which is given 1903, the earthquake are the causes by the pieces of the crust and earth that suddenly shift related to each other. The most common causes in earthquake in faulting. The fault is breakdown earth crust along the which is movement is occurred. So let's see. Mm, Here is our the earthquake. Earth means land and quake mane quick means in vibrating. So here is some different between repair and retrofitting. Repair, which is structure already going to the damage, then we will work in damage work. On the other hand, retrofitting the structure have no damage yet, but it will be damaged in very future. Drift mean is sliding or deflecting something. So we've been here is the focus. If we see here, if the earthquake is occurred, then we can see this is the earthquake is a focus and hypocenter, and the vertical between hypocenter and land we can see the epicenter, and the vertical horizontal distance between the structure, it could be building, and between epicenter is called the hypocenter. Okay, so epicenter is we have been given here, shown here. uh, so let's see another is earthquake terminology. So here is the earthquake terminology, the first option. We can see here the lots of wave. We can see PF, S wave, and the S wave is divided also two F, which is a lava wave and relay wave. So PF is the vertically, it will be up down in vertically, and the vibration will also in vertically. On the other hand, you can see another one S wave, which is move. It will be moved in vertically, but the vibration will be left and right side. And then we can see S wave. When the S wave is occurred in surface, then we can call the lava wave. When S wave is occurred below the surface, then we can say the railway. So let's see the picture of the different type of wave. So you can see here the some type of seismic wave we are showing here. This is the pre-wave, which is the compression we've been seeing here, and the expansion we've been here. And we can see here the S wave is undulating occurred here, and the twist of the amplitude we've been seeing bit different between here. And this is the lab wave we have been seeing, and last one is a rail wave. Okay, so Let's see. uh, okay, so the earthquake terminology has ended now. uh, Now we can see the earthquake ground motion, the second term we can earthquake ground motion. Here we can see the ground motion we have been seen in our picture. As we have been seen, the maximum PGA is found about 10 and minus 10 and plus 10. So we are taking the plus 10. The ground motion we have been seen keep per feet square. So the maximum ground acceleration 10 feet square. We know the ground acceleration which is 32.2. So if we divide it the maximum ground motion we divided by below 32.5, then we found 3.31. So this 31 will be used in ETFs as a jet value. As we know, the different jet code value is 0.2, 0.12, 0.20, 0.28, 0.36. So these are the coming from the maximum acceleration. So we've been seeing another ground motion. We've been found the maximum acceleration found by in 7 feet per second square. If we divide it in the acceleration is 32.2 and 1.53. So this is the maximum jet value we can use in EDEPS and others where we need it. So in this way we can see here this point 3, the frequency we can see here, the x-axis is in cycle per second, in x-axis, y-axis the ground acceleration amplitude. We have been 0.31 and we have been from frequencies also 0.53 is y-axis. So if uh, if the earthquake is matched with the ground motion, then the structure will be collapsed. So we should not match with the earthquake ground motion with the structure. Okay, let's see um, another terminology. Now we'll go to the second portion, which is earthquake magnitude and intensity. So let's see the earthquake magnitude and intensity. So earthquake magnitude and intensity, we have been found lots of formula. In this way we've been seen ml, which is the local magnitude, which is log a by a naught, and found a is a moment amplitude is a micro 10 to the power 10 to the power 6, and a naught is a friction or distance. It will be calculating here. mb is a body wave magnitude, and log a by t. A means the amplitude of ground motion, t is a compression period, and q into del is the angle between empirical station in degree, and h is the vertical distance of the distance between focus and epicenter, and s is the surface wave. We have been seen log a by t into 1.6 log 10 d plus 3.3. So we've been seen here is the ground motion. We've been seen the first is the body wave. In this is the body wave, and this is the surface wave we've been seen here. So we have been said that the surface is very harmful for structure, as it is vibrating. Right side and left side in the structure. See, here is another is ES. ES mean the radiated seismic energy. M naught is moment, which is G into AD divided by 220,000. Okay, so we can see another log into ES. ES is the energy released in kilonewton, and 1.8 to 1.8 plus 1.8 into m. M is the moment magnitude. So here is the seismic moment. Another one we have been seeing the one of the soil is taken in the in y-axis. It is also y-axis, and B is, we can see D here. So D is taken here is the drift or deflected. So strain will be B into D. So this is the B and this is the D, and B is a displacement toward left side, and D is a D is a displacement toward the left side, and B is a displacement toward forward side. and shear stress tau equal to B into shear strain. Stress, we know the modulus of elasticity into strain. So we are using G into shear strain, and strain equal to have been found D into B and putting here. And shear force, we know the shear stress into area. So shear stress we have been found and area have been found. So moment stress, we know the moment is the force into perpendicular distance. So force we have been found the shear force here and putting here, and perpendicular distance is been. In this way we have calculating the seismic moment, which is GDA. Okay, we have been another seen the moment magnitude MW equal to log m naught into 1 divided by 1.5 into minus 10. So if you moment is given in dial, then we can use this formula. Others we can use moment magnitude when the log m naught is kilonewton meter. So we are using this formula as usually when the moment will be found kilonewton per meter. So we can see another compression among the different earthquake magnitude scale we have been seen here are MW, M surface body of, and the OXC CCM. Okay. We have been seeing the modify Markeli intensity scale MMI. That intensity scale is based on the mainly effect of the earthquake rather than the magnitude. So MMI we have been seeing M1, 1, 2, 3, 4, 5, and to the M. So if we give them another, it we know the what is the modify explanation. Then if we go to this description, then we have been found what is the I. Here we have been seen 1, 2, 3, 2 x. So I 1 is a not fault except by the very few under the specially favorable condition. So intensity 2, this means felt only fewer person at rest, especially upper floor in building. 3 means felt quick noticeably person indoor, and 4 is felt indoor by many and outdoor few during the day. And the intensity 5 felt nearly everyone, and intensity 6 is felt by all and many frightened at. And intensity 7 damage negligible in building, but of good design and consideration. And intensity 8, the damage slight in specially designed for structure. And intensity 9, damage consideration in specially designed for structure. And 10, some while building wooden structure destroyed. And intensity 11, which is few if any masonry structure remain standing. And intensity 12, damage total, and line of sight of the level of destroy. So these are the meaning of 1 to 10 modify Mercalli scale. So if we know the what is the difference between moment and magnitude, if we know the difference between now we'll go to the where is I? So I'm completing here the now I'm going the difference between magnitude and intensity. So here is the difference between magnitude and intensity. So magnitude and intensity, magnitude is left side and intensity and right side. So earthquake, how many energy is released? It is related to magnitude. So how many energy is related? On the other hand, intensity means how much is harm or how much is damage is occurred in building. It is related to intensity. So the magnitude is related to energy release. On the other hand, the intensity is related to harmful of the structure. Okay. So it is related to energy release, and the intensity is how strong earthquake feels to observer. So it is the feels of to the observer. Magnitude, the quantity measurement of the amount of energy released by an earthquake by modern seismograph. On the other hand, quantity observation of the kind of damage done by the earthquake. and magnitude depends on the size of the fault and that breaks, and on the other intensities depends of the distance to the earthquake and strength of the earthquake, and magnitude is finally measured by Richter scale. On the other hand, intensity is measured by Mercury scale, and we can see the denoted by digit number 7, which is magnitude 7.68867. On the other hand, the intensity is equal denoted by Roman number 1 2 3 4 6. So it is if I conclude that the magnitude is totally depend on the release. On the other hand, intensity is how much earthquake feels the observation. So if we cannot design in terms of magnitude, but we can, if you give the intensity, then we can design the structure. So in the modern design, we know the earthquake resistance design, or we can say um, performance based design is related to the intensity. So if you wanna design and performance based design, then we can use the intensity. Okay, so if you give that intensity, the how much structure will be survived, then we can use the intensity, but we can use the magnitude. Okay. If noted that if the intensity is beyond the 7, then the structure will be damaged. We cannot use the magnitude for the designing, but on the other hand, how much intensity we will give, then we can design the structure in terms of given the intensity. If you know the, if you want to design in magnitude, then we want to know how much the earthquake is occurred is where, how much far away, how much rupture is here, how was the epicenter, and etc. etc. So it is quite impossible to know. Now we are showing the empirical relationship and estimation of peak ground acceleration. So you can see here the some empirical formula is given by Millen and Davenport, which is given found the peak ground acceleration jet, and by only Davenport, and the Ista and Bilibinda, this is the found for here. So we have been known Z is the peak ground acceleration, and M is the moment magnitude, and R is the distance from structure to epicenter, and RH is a distance from structure to focus. So this is the RE and this is the RH, and this is the focus or earthquake will be happened here, and this is the epicenter. So there are lots of thousand relationship is will be found in online for calculating peak ground acceleration. But I've been reading here the Professor Dr. Iftikhar sir, professor in University of Asia Pacific, Dhaka, Bangladesh. He tasked us for calculating peak ground acceleration only the three formula, but he said you can use thousands of formula as is the empirical formula. Okay, so we can see the PGAs during the shaking of different intensities, which is given bold in 93. So if you know the MMI Mercury moment and intensity, which is 5 to 10, the shaking type will be moderate, which is PGA value is 0.04, and for 6 the strong ground will be acceleration, and for 7 the very strong ground, which is the Z value will be 0.10 to 0.15. As we know, it is taken for in our zone coefficient. We can consider zone coefficient 1 in Bangladesh being BNBC on National Building Code. and PGA value is severe point, when the MMI is 8, then we can use the severe value 0.25 to 2.30, and the intensity we can use the zero point 0.9, which is the violet, and the PGA value will be 0.50. And if you consider the extreme case, which is 10, then the PGA will be 0.60. So this is the PGA during the shaking of the different intensity. We can use ml 2 into I naught divided by 3 into plus I is the intensity or PGA value. Okay, so let's we have been completed the theory, and now we'll see the some math examples. So let's see. Use the standard surface wave formula to calculate the magnitude of earthquake if it is originate at the focal depth of 500 kilometer, or the maximum amplitude of ground vibration recorded at the empirical distance of 5 kilometer is 10 cm, and the frequency of surface wave is 0.5 hertz. And second, we have to use for this earthquake, calculate the ground vibration amplitude at the epicenter is given 500. So using the standard surface wave formula, we know ms equal to log a divided by t1 plus 6 is log 10 into t plus 0.00. So now we know the use to surface, we can calculate the surface uh, mm, surface wave. So we know the maximum amplitude motion 10 centimeter, 10 divided by 100 into 10, so we are calculating micrometer, and we are taking the micrometer, and t equal to, you know, the 1 versus frequency, so frequency is 0.5. We are seeing here uh, here is given is 5, the frequency is given 0.05. So we are in this way we are calculating the time period, and d is d 5 divided by 500, so it's given is 5, and 500 we are calculating, we are dividing 5 kilometer is given, and we can see the 500 kilometer also in given in question. Here is the 500 kilometer is focal depth is given, and we can see 5 kilometer is epicenter distance we have been given. That's why we are calculating d. This is the d value, and found in radian, and we are multiplying 180 and dividing the pi, and found in degree, which is 0.573, and putting the wall value is here, and found the surface wave 6/60. And the surface we have been calculating the surface wave. We see here ms equal to log 1 by t into 1.6 is log d into t, and putting all this value, and found a equal to 0.21 centimeter. So this is the body wave, and this is the surface wave. So this surface wave we have been found 0.029, and that's all. So let's see another example. Show an earthquake ground motion vibration data recorded an epicenter distance from 10 centimeter, and the focal depth of the earthquake is 200 kilometer, and the frequency of surface wave is 0.5 hertz. Calculate the local magnitude of the earthquake ml, and intensity and sustainable epicenter, and peak ground oscillation by only Stabila and Stiba and Bilabendra. Stiba and Bilabendra formula we have to use. We have been shown the lots of formula is given here. So we can use here Stibila and Bilabendra. So there is another formula, but we will not use. And energy released by the earthquake and seismic movement. So we've been seeing the ground motion is here. So these are the given in question. So now we will use d, which is we have been seeing 10 divided by 200. So in given in question, 10 divided by 10 is the epicenter distance, and 200 is the focal depth is given. and f equal to given 0.04, and the time period will be 1 by f frequency, which is 20 centimeter, and a is the moment amplitude. So 3.5 inch we have been found here. The maximum found 3.5 is a 3, and this is the 3.5. It is taken from the graph, and it will be we have been use divided 12 as it is taken to inch to feet, and multiply with 3.25 is taken to meter, and we have been used 10 to the power 6, which is the micrometer. So the already the unit has taken micrometer. Okay. So local magnitude ml, we know the equal to maximum amplitude 3.5 inches found is graph, as we have been seen here, and we are taking is into micrometer, as usual we have been taken in previously. Notice 1 is always 1, we have to take the notice always 1, and found 4.95, and the intensity we have been used ml 2 divided by 3 m not intensity plus 1. So we have been taking the local magnitude, and in this way we have been found the intensity 5.925. Okay. So the and we can use the PGA. We have been used PGA value by Stabila and Bilavinda formula have been used, and we know the RS equal to 200 kilometer as given in question is a focal depth, and m equal to ml 4.9 we have been found in the previous calculation 4.9, and putting one value and found 0.005. So this is the PGA below. We can use in E taps in Z below. Energy release in earthquake, we know log into ES into 1.8 into 1.5 into M. M equal to have been found, the M equal to ML. ML is local moment, and we have been found 1.68 into 10 to the power 9, and we are converting in kilojoule, which is 1.6. Okay, seismic moment will be m naught es divided by 200. So we are using es equal to kilonewton, that's why you are taking here kilonewton and divided by 2000, and found 8.4 in 10 to the power 5 kilonewton meter. So this was in that. So another example we can see here, an earthquake of moment magnitude is 9 original from the fault at epicenter E is Shohid Romejuddin College, Cantonment College is shown in below here, the Shohid Romejuddin College, and the propagates over the rupture area with this rupture area is given 100 kilometer, and depth is 700 kilometer through the underlying rock having shear modulus is given 100 GP, and calculate the we have to calculate here the distance is from gate is given 10 kilometer. The we have to calculate the average displacement of the fault plane, energy released during the earthquake, and PGA at farm gate area F is given here 10 millimeter from E, which is using Milne and Davenport equation. We have to use PGA. We have been seeing the three equation we have been used here. The Milne and Davenport we have to use here, and we are seeing here the three equation we have been SAR has used here. Okay, let's start. We have been shown MWO is given 9, so moment magnitude is 9, and B is 100 kilometer is given in question, and we have been taking the meter, and D is 700 meter is given, we have been taking convert into meter, and G is a 100 GPa, we have been taking Newton per meter, and A is given 100.3 which is here, and into 70B which is B into D, and found at the meters is rupture area, and average displacement we are calculating MW. MW equal to log m naught in divided by 1 plus 5 minus 4, and in this way we have found the m naught 3.16 into 10 to the power 7, and we know the moment magnitude equal to GDA, and putting all this value and found the unknown d, which is the average displacement 4.51 meter. So we are using moment magnitude is again here, and found the 4.9 into 10 to the power 25 Newton per meter square. And energy release in earthquake we know, log ES equal to 1.8 plus 1.5 into m. And in this way we can calculate the energy release, how much energy is released. Now we can calculate PGA by mine and Davenport equation, and putting all this value and found 5.9.7. Okay, let's see another example. The peak ground motion acceleration in earthquake released to be 1.5 meter per second square and 2 meter per second square at two recorded station is 10 meter apart. Okay, so use the Davenport. So there is another formula, Davenport question, to calculate the magnitude of earthquake as well as epicenter distance of the two station. Okay, let's see. So you can see here the question is given the 10 millimeter from 1 is 1.5 meter per second square. If we calculate and if we divide 9.1 as it is given meter per second square, that's why we will divide in 9.9. If we keep this feet per second square, then we can divide 32.2 and found jet below 0.153. In the same way we have been found the another station B is given 2 meter per second square, and if we divided 9.1 and found 2.204. Okay, so now we are comparing RAB plus RCB equal to 10. Why 10? 10 is given here, 10 kilometer is the distance is given here, and we can see the RCB equal to 10 minus RCA. It is the equation 1. Now we are using Davenport equation, Z equal to A is where for station 1. So we are calculating for station 1. So using Z value is we are already calculating here 0.153 and putting all this value and found another equation. And for station B we are already calculating the Z value is here 0.20 for the maximum peak ground acceleration, and putting another equation. Now we are solving two equation 2 and 3 and found the RCA value, which is 5.44. So this is the 5.44. If we minus 5.44 to 10, we can use the RCB value, which is 4.56. Now station A we can use this formula and found magnitude which is 5.06. So these are the answer. Now if we check this again, then if we use the Z value and M is unknown, and and we can use the reverse calculation and found M equal to 0.05. So in this area we can in this form we have been found 5.05, and in this way we also 5.01. So M equal to MB, moment magnitude is always same. So station 1 moment magnitude and station 2 moment magnitude always same. I'm just checking here, so you don't need it. So another example we have been seen, we want to see there the PGA is measured to be 8.6 meter per second square at recording station and earthquake magnitude is 6. Calculate the epicenter distance and use the mine and port Davenport and use that only Davenport equation. Okay, let's see. So we can see the another the PGA is found 5.86 and we are dividing 32.5 as it is given in feet per second square. Sorry, it will be feet per second square in this way here, and we are dividing 32.5 and found Z value which is 0.25. Okay, so by mine and Davenport we have been equation here using equation and found the RE value 17.05. And if we use the Davenport equation, putting all this value and found RE value 11.47. So these are the this is the bigger value than this value. So you can say the my Milne and Devonport is taken the more value compared to the Devonport value. So which value will use? We can use the more value, Manly and Devonport. Okay. As my assumption, you can use all things as engineering judgment. The peak value acceleration, the peak ground acceleration of earthquake of magnitude 6 and is measured to be 3 meter per second square at the recording station. Calculate the epicenter distance of the recording station using Devonport equation and PGA using Milne Milne Devonport is 1969 at the epicenter distance of calculation here. So you can use PGA as 3 meter per second square and divided by 9.8 and pound 3.31. This is the jet value and put using the Devonport equation and found the R equal to 10.06. And the same value will be used, but we are using the another formula mainly and Devonport it is given and pound jet value equal 0.14. Now we are calculating jet equal to PGA and found PGA 1.36 meter square. So this is the another answer. So you can see another one calculation. The warning time, calculate the warning time, and data is given below. Hypocenter distance is given 1000 kilometer through the very hard limestone with the modulus of elasticity 10 gigapascal and Poisson's ratio is given 0.10 and density of sand is 2500 kilonewton per cubic meter. So hypocenter distance is given 1000 kilonewton. E is given in gigapascal, but we are converting in Newton per meter square, and Poisson's ratio is given and density is also given at in sand. Now using modulus, so I am equal to E1 minus Poisson's ratio divided by 1 plus Poisson's ratio minus 2 1 minus 2 Poisson's ratio. Using this formula and found modulus. And shear modulus we have been used G, which is E divided by 1 E divided by 2 into 1 plus modulus Poisson's ratio and found the shear modulus. And the velocity of P, so POF will be velocity of POF, so BP equal to root over m by P and found 5.36 kilonewton per meter square. So share of velocity BS, so BS we have been found root over G by P and found 3.5. We have been found 5351 meter per second and converting in kilometer per second, and we are also found 3560 meter per second and converting kilometer per second square. So you can see the POF is greater than SOF, and the time error bar P equal to TP hypocenter distance into BP. Hypocenter distance we have been taken the 100 already mentioned. Hypocenter distance is here 100 is given and divided by BP and found 18.63 second. On the other hand, arrival time of SOF, which is hypocenter divided by PS, and found 28 seconds. So warning time we can see TS, which is the SOF minus POF time, and found 9.331 seconds. So 9.31. If the if the earthquake is occurs and we have to get out from our building, and will getting the time is 9.31. Otherwise we will be die and the building will be suffer from earthquake after the 9.31 seconds. So you can see here the POF we have been found 18 seconds and SOF we have been found 28 seconds. So this is our warning time between between the earthquake. Okay. So that's all. If you have any question, I have completed this today's lecture. So If you have any question, then let me know. I will try to answer your question, and I will try to convince your question. uh, Thank you everyone, thank you. If you have any question, then let me know. I will try to convince you. This is the totally we can say the theoretical, but we have been complete this theory and this math. The math is important as the civil engineer or the earthquake engineer or others if you come from others background. So if you have any question, then write or mail me or comments me. I'll try to explain this. Thank you everyone for your patience.